Ray, and I'd like to talk to you about CrowdSec and my experience when I was at the LinuxDay in Dornbirn. It was kind of a funny experience, and I even gave my last shirt for you, so that's the reason why I'm not wearing a CrowdSec t-shirt today. So what is the LinuxDay in Dornbirn? We are there at the HTL Dornbirn, which is basically a school, and we want to educate folks about Linux. So what we do is we show in workshops how to work with certain topics. We give speech presentations. Even I did a presentation about CrowdSec, and I'm really thankful they helped us out on the network by sponsoring us the firewalls that we needed. So I'm Ray, and if you want to know more about me, stalk me on social media, look on GitHub what I do, feel free to look at links.stargazer.at, and that's where my social media stuff is linked and all that. My topic was the IT crowd is coming. I mean, think about it. The sysadmin's life in a nutshell is best compared to a tragedy. It's a form of drama based on the human suffering that invokes an catharsis or pleasure in the audience. That's pretty much a very dark description of our life as a sysadmin, but it doesn't always have to be that way. If we look at log files, and this is what we do most of the time, we do see a lot of stuff. Failed logins, script kiddies trying to really get into our systems. That's kind of annoying. And I could even show you right now, what's happening on my box, and it wouldn't look any different than that. As you can see, I just logged onto a machine here, and we already have some stuff in the SSH unit journal, whatever you want to call it, in the log files. And as you can see, connection closed, failed, password for root right here. Another one is just the way it is. So this is common log spam that we see over and over again, and it's just happening. Well, is cybersecurity a problem that can be solved by throwing cash at it? Look at the numbers here. It's like Equifax, they've got a lot of records, a lot of users. Microsoft, their mail servers. You can't just throw money at the problem. It does not work. I mean, look at the big players. Even they had security breaches. They had problems. Look at Facebook with their 267 millions of records. Twitter, well, okay, Twitter is a different beast right now, but still. JP Morgan. And let's have a look at the sheet for marketing, the overview of the world's cyber threats. Now do me a favor and please scream out, be shocked, because that's for the marketing, so they did do a good job. And if you really want to do a good job, please subscribe to my channel, and it just takes a click and it helps me out a lot. Anyways, let's have a look at the solutions that we currently have. Fail to ban is kind of an old thing. It was done around 2004. That's 17 by now, around 18 years ago, and it's kind of old-fashioned. So it doesn't scale very well, and it still uses regular expressions, which I consider to be a write-only language. Yeah, it's really hard to understand what you've written back then. Even I have the problem when looking at my old code, so that doesn't really work out very well. Let's have a look at CrowdSec and the lovely alpacas looking in. We use grok patterns, and they are so much easier. slightly newer. And the best thing is they share lists. And we don't have to have the parser and the bouncer on the same machine. We can, but we don't have to, which is a good thing because I can have my parsers running on every host in my network and have the bouncer sitting on my firewall, which is absolutely fantastic. Let me quickly bring you up to speed. CrowdSec is not just a new version of fail2bane. I mean, it could be seen as a rewrite, but it's more like a log analysis tool. So whatever you throw at it, it can detect anomalies. Anything you write a pattern for, it can be bot scraping, credit card stuffing, data exfil, anything really. The limit is your imagination. And I have written a parser to fit my needs as well, so it is not that hard. Even I could do it. So let's look at the thing. Outpowering the script kiddies. Outsmarting them. That fails. It's time for a new approach. We never really tried out numbering the cybercriminals out there. Think about it. Do you know the app Waze? It's basically a reporting in incidents, and we just distribute the information back out there. And this is what CrowdSec is all about. It's about the crowd. It's not just having the information for yourself. It's about sharing them. And what that does for you is really amazing. And I'll show you that in some numbers a couple of slides later. So at first, what we do is we acquire the data. We run the log files. So systemd, journald, whatever you throw at it. It could be a Docker log, Windows event files. Well, basically anything. In that, we try to detect what's going on, like in, well, IDS. This is really about detecting anomalies, like failed password. And then we try to remedy that by blocking the IPs, and this is the first step it does on your local machine. It just blocks the offending IP to prevent it from wasting further resources. That stuff is shared back to you, and those IPs, they do have a reputation, so that gets back to you as well. Everything automated, of course. Think about it like that. We can detect web scans, port scans, everything. You know, ransomware attacks, targeted attacks. It is so amazing. I'll show you. One very important thing is we are complying with the General Data Protection Regulation. This is because it was built that way. All we send in is a timestamp. When did the attack happen? The offending IP, this is who did something wrong. And the behavior, was it SSH brute forcing? Was it SIP abusing? What did that bugger abuse? And it is open source, it's forever free. That is very important. So it is transparent. It's absolutely something you want to integrate. There are no costs, no hidden strings attached. Look at the source code, fork it, modify it, improve it, contribute. There is something that we do monetize, and this is really access to the CTI. That's for the information that you do not share. Think about it like this. If you report attacks in, you get data back. If you don't want to report data in, but you still want to get the data back, or just want to get the data, you'll have to pay for it. I think that's pretty fair. So how does that thing work? We've got a database that's called the smoke database. And this is where all the signals come in together. And then we try to find a consensus. That means if an IP gets reported over and over again just by one instance, it doesn't do much, because that could be just abuse from that one person. And so we've got a trust level to your sensors, your parsers, and they all get tiered. And we also have honeypots out there, and they do have a trust level of 100. So there is also a whitelist if you have something like native providers that you have to, well, that you can't block. And we have a predictive algorithm, which is basically something like if you have a network, a class C network filling up, and there are just 5 IPs left, well, just block them as well. And if we come to agree to the consensus, we get that down to the FHIR database, and this is what's actually getting shared. That's the thing that we give out to you. That's the list. But how effective is that thing? Do you have an idea? We'll figure that out. So, first things first, we do run nearly everywhere. You can see Debian, I think that's Fedora. It's nearly any Linux distribution. It's written in Go, so it's a run everywhere. It can run on Windows, BSD, in containers, Docker. It is amazing. And as I told you before, we can crunch on files, journald, syslog, a CloudTrail. If you want to throw a Kinesis stream on us, do so. Docker logs, Windows event logs, anything. Just give us data. That's basically give us a log file, show us what is wrong in that data. So that's what the pattern is about. And then we can block the malicious IPs. We can do that at the provider level, at the network level. So we can just throw in the list into your IP tables. I can also just spit out a list that I feed to my firewall. That's what I do with the pfSense. You can do something like on Nginx. If you can't block them at the firewall, you can do it in your application. There are libraries. So let's say you've got a blacklisted IP or blocked IP to be politically correct. What you can do is really write a rule in your application that you present them with a captcha or whatever. BGP blocking is still work in progress. Why are we doing this? Think about it like that. You've got an ISP, an internet service provider, who does not care. As long as you pay them your fees, you get internet access. This is basically very, very, very bad practice. Because that way, all you have is a network full of malware, full of cyber criminals, full of trouble for anyone out there. And this is why the internet is such a problematic place. And what we do is we try to enforce providers as a community to clean up their networks, which is very, very important. And what I was talking about earlier about how effective is it, look at this diagram here. We've got the blocked by reputation, which is basically the whole thing, and blocked by behavior. Blocked by behavior is what you actually find in your logs, and blocked by reputation, that is what you basically block even before something happens. These are the firewall rules that you have in place because of the CrowdSec community, because of a block list, because you share data, and that is a good thing. So think about it. You are saving a lot of stuff. And now this is something where we need to talk about. CrowdSec is not the wonderful miracle. Magic doesn't happen. If you want to, feel free to pause the video and think about that picture and what it could be about. I think you might obviously see this is a plane. And this was a plane used in World War II. And every red dot here is a bullet hole or anything damage done to the plane. Yeah, now, is this data accurate? No. Because this is because we are biased. Think about it like this. Why are there no holes recorded in the engines or where the pilot was sitting or at this, well, flimsy part of the plane? Because this is why we have those problems. The samples taken and the data collected, that was just from the planes returning from the battlefield. So think about it. If an engine gets shot out, the plane crashed, it couldn't return. So we didn't have the chance to, well, get that data into our statistic, which is bad. But yeah, this is also the problem with CrowdSec. Everything we do get is what's in a log file. If you can't log the attack, we can't do anything against it. So this is something you always want to keep in mind, but it's about the background noise. We can eliminate all the other dots and we can really focus on a few of them. Now, what does this mean in terms of CPU usage? I'm running a home server with a couple of machines. Okay, I admit it, I run a lot of stuff on it. It's about 10 virtual machines, a few containers. Pretty much a large thing. And well, for now, please ignore those spikes. This was just me compiling updates. This was, I think, a kernel release that I had to compile on multiple machines. My baseload, which consisted of the web server, mails, you know, all that stuff that you needed in a home lab, gave us a baseload of around 30%. This might not seem much, but then I installed CrowdSec, and this is around here. And you see it really dropped the baseload down. Every time somebody attacks my server, I had to react. Think about it like this. Somebody is trying to do something weird with your blog, with a WordPress site. What does a WordPress site consist of? It's the database, it's the PHP, FPM, it is the web server. So every time a request comes in, we kick the web server. The web server kicks PHP, and PHP might kick the database. Database gives stuff back to PHP, and then we do something to generate a website output, and we send that back to the client, whoever that might be. And every time somebody searches something on your blog, even if it's just bullshit for, you know, SEO purposes or whatever those bots pretend to do, or just trying to exploit, you are hitting the whole stack. This is really work for your machine. So in my case, it really halved the load on my server. So I could run additional virtual machines, and that's what I did. So in the end, I did benefit from that a lot. But CrowdSec is not a web application firewall. We can't detect SQL injections or anything like that. What we do is really, we figure if there is someone testing your server. So what you get is really a cleaner log file. Now let's just beat a dead horse. The log4j incident that we had back then. Do you remember it? If not, I would recommend you pause the video and do your research. And just hit up your search engine of your least mistrust. It's really easy. Just look at it. What is log4j? Some basic information about the CVE, so you can look it up. Log4j is a library in Java that is used for writing logs. And as you can see from the picture here, this was also used on the iPhone 12. So yeah, it is nearly everything. So much stuff written in Java, so much stuff is using the Log4j. Even games, Minecraft uses Log4j as well. And I think that is why that stuff really blew up that bad. And boy, that really escalated quickly. I had to put that there. It is just so tempting. Think about the timeline. The Log4j incident, everything was published around December 9th. CrowdSec, we've written a scenario the day after. I think that's fair. We also need some time to figure out what's going on, and so we were doing our best. Then we had the first scenario down, and we had also a spike of signals when we updated the scenario and adapted. And as you see, we had it all in check around December 20, including Unicode support and all that fancy bells and whistles. I mean, that was more or less the beginning of CrowdSec. And let's have a look at the attacks and the signals coming in. So that was December 10th. December 11th, we had already the first signals coming in. We optimized, and we have a huge spike on December 13th. Let me take you back to the timeline. Okay. That escalated quickly, right? And that was a lot of signals coming in. And if we get in, well, 7 months of Log4j, well, that's kind of a mess here. It was exploited quite a lot, and then around January, when people really patched it, or a lot of patches rolled out, cyber criminals thought it wasn't really worth it and the curve. And this was really the Log4Shell attacks, and by today, I mean, we are talking about July 20. So yes, this data is a bit aged, and it aged well. I held that presentation on the LinuxDay last year, and that was around October. So just keep that in mind. I just wanted to record that presentation for you again, because I'm still in touch with CrowdSec, I'm still an ambassador, I'm still alive. So as you can see, the IP was reported by more than 500 instances in the past 12 hours. So just think about it. This single IP attacked more than 500 instances. If you look at that spike here, that's more than 800. So just keep that in mind. Those attacks happen automatically, automated, and it's a lot happening. So that IP and a lot more IPs just kept punching on innocent servers out there. And as a sysadmin, that really hurts, trust me. So, is it over? Think about it like this. We've got a VMware Horizon security bulletin, and if you look at the date down here, it is released on June 23rd. And that was months after when the exploit was first published. So I think there are still exploits out there that do work. So think about it. Your IoT doorbell or whatever, your lock, your whatever thing you've purchased, you've built that into your house and you never have updated it, or it's already end of life. So that stuff is still vulnerable. And that is what this should show you. So Even if they claim an exploit might be fixed, it could still be exploited with some fix. Well, why do we need a dynamic block list? Think about it. Cybercriminals don't always use the same IP addresses. As you see, only less than 3% are really permanent. That they are all-time bad actors. After some days, let's say 1 week, it's only 12% still active. So they are really moving fast. This is why we need a central block list. This is why we are really working on that. And this is why CrowdSec is so important to just fight them. If you look at the block list journey, the IP gets, well, reported over again until it drops out. And as you see, this is really after 1 or 2 weeks, they just drop out. So there is no need for manual whitelisting. I mean, of course you can, but this is nothing that does really work. That's why we don't prolong a listing artificially by repeated offenders, because they do get reported. They come back. So yeah. If you look at some hosting, well, companies, ChinaNet, Deutsche Telekom, you might say geo-blocking is something that could work. Help you with that? I really have to disagree. Think about it like this. You have a server sitting in Germany, let's say at Hetzner. It's a popular hoster, not sponsored. It's just a brand that I often have servers at, so I don't blame them. They are really good with cleaning up, so no offense. But let's imagine we have a server sitting there. So we have geo-blocking in place, and we block everyone, say from Russia, China, whatever. We only let people from Germany access that server. And we are all fine and dandy. And sadly, some hacker located in a country that we block hacks a server or a customer or whatever in Germany. Okay, think about it. Now this, hacker uses that IP and keeps on cracking on other machines. So now we have an attack that was coming from Germany, even if it originated from wherever else. This is really common what people do, so geo-blocking isn't really an option. Think about it like this. How many attacks are there? Let's quantify that. SIP, voice over IP, we've got a lot of signals coming in. So this is really, as you see, 38,000 attacks on top. And I think those average out at around, let's say 18k, 18,000, 15,000. Well, it's a lot. But there is something even worse. SSH. Just look at the sheer number. And on SSH we do have brute forcing and slow brute forcing. Slow brute forcing is really, let's try one password on 1,000 IPs, then rinse and repeat instead of hammering on one machine. This is what people did to combat fail to ban. And we do really detect that because we are accumulating data from a lot of machines. And as you see, we are getting an average of 500,000. Just compare the scale. Well, that's impressive, right? And we have a lot of threats being reported. A lot of them are SSH related. That's around 50%. Then we've got bad user agents, like, think about it, there's something crawling your web server or files that it shouldn't be able to access. You know, just randomly trying it out. Maybe somebody has a misconfigured server, and yeah, take that maybe as surely someone has, and then you are really close to reality. Postfix spam, HTTP probing, and it's kind of a messy thing. Even I wrote a parser for brute forcing on my mail server, and it was zero. And we are safer together. I mean, think about it. We collaborate. We've got a dynamic security engine that's working. Password being done? Oh, I forgot the open source. Creating parsers is absolutely easy, and I did that. And a parser consists of a skeleton file. This is basically a description. You wanna filter everything, you wanna debug and just go to the next stage. So the red part is pretty just standard stuff. The grok pattern is where I'm looking at messages, and the statistics is really what we are monitoring, if it's an or whatever. That's a parser skeleton file. Pretty straightforward. That's all you need to know on how to create a parser. Grok is really easy, and I use the grok debug that's running on the Heroku app. And this is really golden for building that stuff, because you can paste in a couple of log lines and build your parser, and you get to play around with that. And you can really fiddle with it until you get that stuff right. And with grok, I prepared a neat cheat sheet for stuff that you might want to use. Hostname, IP, and even a number, or whatever there is. Let's go over it quickly, okay? Username or user, you don't need really to distinguish between user or username. We just grab that. IP or host, which is usually with regex, is just a pain in the rear end, because you have to say, okay, is it an IP, is it a host name? It's a lot of regex to get that right. We can also say, is it a host name, is it an IP? So that's pretty, you know, IP or host name. Bang, you're done. Then you have a number, a path. Data is basically a catch-all. Timestamps, commonly used. We've got the ISO format in common logs, so that's pretty useful in there. Not space, anything that's not a space. So greedy data is catch-all. Pretty neat. Feel free to use it. So how does that work? You really write that YAML file, and you've got that thing. As you saw, the skeleton, that is YAML. And we run a leaky bucket. So we have our filter set. Does it match? No. We're done. Do we catch something that we want to catch? Yes. Okay. So we just go to the pattern matching, and do we have attacks already? If we have, yes, then we're good. We're already blocked. And if no, we have something like a grace period, or something like, you know, you can have 3 failed logins until we do something, and that's what the leaky bucket is. And if we have an overflow, then we just send the alerts and we're good. What is a leaky bucket? Think about it really like a bucket or a cup of coffee. And we are having a leak, so water constantly drips out. And every incident adds, on top of that, adds some water. And then we've got a rule when it overflows. So let's say we accept like 10 failed logins in a period of, let's say, 3 hours, and the 11th one will make it. So I'd say thank you for your attention. And if you have more questions, I'll leave the link to the CrowdSec Discord in the description. And feel free to catch me there, and we'll have a lovely chat about anything you wanna